welcome back to the integumentary system. Last week we talked about the skin part of the integumentary system. This week we're going to talk about the accessory structures of the integument. That will include hair, hair follicles, sebaceous glands, sweat glands, and nails. So hair. Your body has about 2.5 million hairs, 75% of which are not on your head. You only have about 500,000 hairs on your head at all times. Hair is found on all surfaces of your skin except your palms, soles, fingers, toes, lips, specific portions of your external genitalia. Hair is considered non-living. It's produced by your hair follicles, and it helps to protect you from UV radiation, cushion impacts to your head. It insulates your skull. It keeps out foreign particles, sweat, or insects. And it has sensory receptors that can help protect you from harm. So the hair follicle structure. The hair follicle opens on the surface of the epidermis, but it extends into the dermis or the hypodermis. There is a root hair plexus that surrounds each hair follicle, which is a collection of sensory nerves that surrounds the base of the hair follicle, and it acts as this early warning sign to prevent injury, so it can sense movements in your hair and to let you know that something's touching you. And this could be something like a bug, like a mosquito, and you know something is on your skin. Other components of the hair follicle, the medulla, which is the core, it contains your keratin. It's the innermost part of the hair follicle. Surrounding the medulla is the cortex. The cortex contains hard keratin, and it allows the hair to be stiff. The cuticle surrounds the cortex. It's thin, it also contains hard keratin, so it toughens the hair. Surrounding the cuticle is the internal root sheath. It surrounds the root and does not extend the length of the follicle. The external root sheath follows that, and it extends from the skin surface to the hair matrix. And then the glassy membrane surrounds all of that, and it is a thickened, clear layer, and it's wrapped in this connective tissue sheath that surrounds the entire hair. Arrector pillae are muscles that are attached to each hair follicle. They are smooth muscles, and they actually pull on the hair follicle to make the hair stand erect. This happens when we get goosebumps. You'll see your hairs raise on end. Now, we used to think the arrector pillae were there for temperature regulation, but it actually only helps with insulation and to keep in heat with other mammals. Humans don't have that function anymore. So it's kind of a rudimentary structure that's been kept around. The hair root anchors the hair into the skin. The hair bulb is the beginning of the root. And the hair shaft extends about half of the follicle all the way to the exposed hair. Hair production will begin at the hair bulb, which surrounds the hair papilla. The hair matrix will produce the hair. The hair matrix is a layer of epithelial cells that lie at the base of the hair bulb. Cells divide in the matrix and the hair becomes longer, and keratinization occurs before cells approach the surface. Scalp hair grows for about 2 to 5 years. So that's about 0.33 millimeters per day that your scalp hair is growing. During the growth cycle of your hair, cells at the root will absorb nutrients and incorporate them into the hair structure. So clippings of hair can actually help with the diagnosis of heavy metal poisonings because these heavy metals can be incorporated into the hair structure. Club hair is where the follicle gets smaller and becomes inactive. The root breaks down and the hair becomes shed and a new hair is formed. So the club hair is kind of where the hair begins to die. People typically lose about 100 hairs per day. If they're losing more than that, that could be a sign of something more severe going on. There are some conditions where you might have a temporary increase in hair loss due to drugs, dietary factors, radiation, excess vitamin A, high fevers, stress, hormonal factors such as pregnancy. Men also can get male pattern baldness where they start losing their hair at a rapid pace. There's generally genetic factors in play here, and it's actually considered a type of alopecia. So the different types of hairs. Lanugo is what forms during about the first 3 months in utero, where a baby is developing. So they have all this fine and unpigmented hair covering their entire bodies, and it's shed before birth. So picture babies in the womb as just being covered in hair, because they are. Those should fall off before they're born, and then they'll be replaced by either vellus or terminal hairs, depending on where the hairs are in location. So vellus hairs are your typical peach fuzz, so they cover the surface of all of your skin. The terminal hairs will be more heavy, more pigmented, and sometimes even curly depending on where they are. So your scalp hairs would be considered terminal. Some vellus hairs become terminal after puberty because of your hormones changing. And hairs can be curly or straight or somewhere in between on that spectrum. If they're more on the curly side, then that just means that the hair follicle itself is more of an oval shape. So it allows for more bending and curling. And if your hair is more on the straight side, that means that the follicle is more of a round follicle. Hair colors due to variations in the melanocyte pigments. Pigment productions decrease with age, and actually air bubbles form at the surface to make it more difficult for these pigments to show through. Dyed hair, when you use hair dyes, it disrupts the cuticle of the hair follicle. It stains the cortex and the medulla, and it kind of weakens the hair shaft and makes the hair more thin and brittle. Sebaceous glands are holocrine glands that secrete sebum, the oil that coats your skin and hair. Sebaceous glands themselves are specifically associated with hair follicles, but you can also have sebaceous follicles, which we'll talk about in just a second. Sebum, or oil, is going to inhibit the growth of bacteria, it'll lubricate and protect your hair shaft, and it conditions your skin. So this is what makes your hair greasy if it's not washed in as many days as yours normally takes to get greasy. It's an excess production of sebum. Sebaceous glands also form the vernix caseosa. So the vernix caseosa is made by very active sebaceous glands during fetal development, and it kind of coats the baby in this like cheese-like film, so that when they're born, that's kind of what is covering them, and it helps to protect their skin from drying out. So these sebaceous glands are very active right before the baby is born. After birth, they slow down quite a bit, and then at puberty again, they speed up. So that's why generally at puberty you notice yourself getting a little bit more greasy and oily. Sebaceous follicles are not associated with hair follicles themselves. They secrete sebum directly to the epidermis. So these are located at the face, back, chest, nipples, and external genitalia. With seborrheic dermatitis, this will be an inflammation around abnormally active sebaceous glands, which can lead to epidermal scaling, which is seen here in this right-hand picture. In babies, that's called cradle cap. In adults, sometimes this can lead to dandruff. And in adults, anxiety, stress, excess growth of fungi or bacteria will increase the risk of getting this seborrheic dermatitis. And on the left here, this is a picture of that vernix caseosa, so that's what the babies are coated in when they're born to protect their skin from drying out. So some say it's actually really beneficial to leave that on them until it kind of falls off by itself. just as a protective layer for the baby, because again, it helps to not only condition the skin and the hair, but prevents the growth of bacteria and fungi. Sweat glands are also known as sudoriferous glands. There's two main types of sweat glands: apocrine sweat glands and eccrine sweat glands. Apocrine sweat glands used to be called so because they thought they were secreted by the apocrine secretion, but they're not actually secreted by that. They are actually secreted by merocrine secretion. These are located in your armpits, around your nipples, and in the pubic region. They begin secretion at puberty. This type of sweat is a nutrient source for bacteria. So when you have remember when we talked back about tissues, we said that apocrine sweat is more of your sweat that causes stains in your clothing and gives you more of a body odor. So that body odor is actually bacteria that's eating your sweat, and it's the breakdown of that sweat that's giving you that odor. So it's actually the cause of bacteria being in that area. Myoepithelial cells help to bring sweat into hair follicles to get it out off of the skin. Eccrine sweat glands are known as merocrine sweat glands. There's about 2 to 5 million within the integument. They're smaller and more superficial than apocrine sweat glands. This is the type of sweat that you get from exercising. Your sweat pH is between 4 to 6.8, so it's more on the acidic side. You also have the highest concentration of these eccrine sweat glands in your soles and palms. So sweat glands help to cool the surfaces of the skin to reduce body temperature. So when you have that eccrine sweat lying on your skin in the form of droplets, when air blows across it, it helps to cool your body. It also helps to excrete water and electrolytes or any waste products from the skin. It helps to provide protection from environmental hazards. It has this germicidin. It has antibacterial properties. When you're choosing between deodorants and antiperspirants, deodorants help to decrease the amount of bacteria on your skin, and it also helps to mask the scent of body odor. Antiperspirants target the sweat glands themselves. They typically have aluminum in them, and the aluminum will plug the sweat gland ducts and cause sweat gland pores to constrict. Mammary glands are in the breasts, and they're used to create breast milk for babies. They're anatomically related to apocrine sweat glands, and their function is controlled by hormones, usually after birth. Ceremonious glands are modified sweat glands of the external ear. They produce cerumen or earwax, and it helps to kind of keep foreign objects out of your ear, especially things like insects. The control of your glandular secretions, specifically the apocrine sweat glands and the sebaceous glands, are controlled by your autonomic nervous system. It's more of an automatic process for those things to occur. Your eccrine sweat glands are more regionally controlled, so you might notice one part of your body starts to sweat more than another due to certain environmental conditions. And as we previously said, sweat glands help with thermoregulation and cooling the body down as air passes over the beads of sweat. Okay, so moving on to nails. Nails help to protect the exposed surfaces on the dorsal side of our fingers and toes. There are many parts of the nail. So we have the nail body, and it's the visible portion of the nail that we can see. We have the nail bed, which is the area of the epidermis that the nail covers. The lateral grooves of the nail, or the folds, are the depressions on either side of the nail. The free edge of the nail is the distal portion, where it continues past the nail bed. The hyponychium is the area of thickened stratum corneum. The nail root is where nail production takes place. The eponychium, also known as the cuticle, is a portion of the root that extends over the exposed nail. And the lunula is this little white crescent shape on the bottom of your nail, where the blood vessels are obscured by the root of the nail. So generally you should be able to see a pinkish type color in the rest of your nail other than the lunula, and that's because of the blood vessels that are beneath there. And that's why also if you injure your nail, you can get bruises there because blood will pool in the dermis like it would anywhere else. So here's a picture showing all of those structures. Nails are keratinized to help waterproof them. They can also be really useful as a diagnostic tool if there's pitting or damage, or they're easily damaged or brittle. If there's clubbing of the nails, these can all be really useful diagnostic tools. There's many different ways that the integument can repair itself. Some physical or environmental stressors can cause the stratum basale to divide more rapidly, which creates a thicker skin, also known as calluses. So when you're using a certain part of your skin more than you typically would another part of your skin, that's when calluses would form. Epithelial cells tend to regenerate after injury, and we'll talk about those phases. An incision is just a cut in the skin. Those will heal faster than abrasions, which will cover a larger surface area. Think of a paper cut versus a rug burn. The paper cut will heal a lot faster than the rug burn will. A contusion is another word for a bruise, so it's just an accumulation of blood in the dermis. And then there are 4 phases of repair of the integument. That's the inflammation phase, migration phase, proliferation phase, and scarring phase. In the inflammation phase, mast cells will trigger inflammation in response to damage. Then in the migration phase, scabs will form. Scabs are really just dried blood clots. This will help to restrict entry of additional microorganisms. The clot will consist of fibrin, and fibrin is the major component of these clots. Fibroblasts and mesenchymal cells will invade deeper areas of the injury, phagocytes will clean up debris, and then granulation tissue will form, which is just this blood clot, in addition to fibroblasts and the capillary network. In the proliferation phase, clots will dissolve, capillary numbers will decrease, and the damaged tissue is replaced by fibrous tissue. And then in the scarring phase, the tissue will not restore to its original condition. It will be replaced with this fibrous tissue or scar tissue. So an area that's typically dense regular connective tissue might scar over and resemble more something like dense irregular connective tissue, so its properties will be a little bit different. There's also variations of scars. Pictured here is a keloid. Keloids are excessive scar tissue formation. People of color tend to have keloids form much more often. Scarification happens in some cultures where they purposely create these complex raised scars on the skin. And then tattoos are kind of similar. So it's an injection of pigment into the dermis, and if you were to try to remove that pigment, you would create scars on the skin. With age, the epidermis and dermis will thin. Basal cell activity will decrease, so it will be more difficult to replace those cells. The dendritic cell number will decline by 50%. Vitamin D3 production declines by 75%. Melanocyte activity decreases, so they tend to be more sensitive to UV radiation. Glandular activity declines. Blood supply is reduced, so they have less of an ability to lose body heat and less of an ability to warm up. Their hair follicles stop functioning, so that their hair will stop growing. Levels of sex hormones will decline. and skin repairs more slowly, so healing will take much longer. So let me know if you have any questions, and you can move on to the skeletal system.